Okay, today I'm just going to quickly talk about just really what the reactive principles in data science, how how really functional programming is making things, all this crazy big data stuff possible. And yeah, it's just making our head hurt. And also I'm saying sometimes don't let brute force do your thinking for you. So, and way too many technologies, so much math. But the thing that's really interesting is what's driving all this. And it turns out that it's really, we started out with Bruce Henderson. This is a TED Talk by Philip Evans. We started out saying that what was driving businesses was just getting to scale and overpowering the marketplace. And then later on we got with Michael Porter and value chains, which is really driven by the cost of the reduction on transactions. But what's really happening, as we are seeing here, the massive amount of data by competing groups. But what's really is the 100-fold increase of data put under your eyes. And then a simple, estimate on the ecosystem is 100 times 110,000. So, what's the best way to join the party? Any ideas? Well, anyway, as we say, I think we've all seen this curve. Big data is going to go through. But the best way to join the party is put your data under rest. And it's easy. You really can just take a simple URI, think of having thinking at some point, at the end you have a database table and the IDs, and you can do some optional query parameters. And then you can create data, insert data, create data with the post, and get back a URI. You can query it with the get. Now this is real basic stuff. You can query it again if you want to put in the query parameters. And finally update and delete. So you've got your basic CRUD. So whatever you do, put your data under rest. Because you won't know how it's going to be used. You don't have to use any data connectors. You can access it with the browser. So best way to join the party. Okay. Some of the most important things that I've found, and I've even talked to, I've had a couple clients start out, who are getting streamed with data like crazy, but they like Mongo. Well, it wasn't a good choice because if you really want to be up here in the A range, and a good example of that, and it's probably becoming one of the most popular databases, is Cassandra in there. Back in the day, relational databases, some people forget that relational databases are still good at availability. And they can be partitioned, but they're not partition tolerant. So this is still the best thing. I've had a couple clients, not know where they belong in the triangle. Now, does CAP tell you everything about databases? No, but it's a very good first start. Okay, so what's making all this possible? Well, one of our associated groups is GridGain. And they don't agree with me on this, but I say their in-memory fabric, which can connect to a lot of the things and support some of the scenarios, is telepathic. Anything that shows up on this grid, their protocols can move to any place very quickly in that grid. Last count, when I talked to them, there's 40 of them. 40 ways to move data around. So that's a pretty good thing. Now this could be good for, gathering sensory data, processing streaming data, and doing small computations. It's not really, like our next thing, like Apache Spark. So again, I'm jumping ahead here, but you can look at GridGain and compare it with Spark, and they've also gone open source to Apache Ignite and say, they're really doing something different. GridGain is more of a generic computing grid fabric, where Spark is more specifically dealing with data processing. Okay, so what's making things happen? Well, this is the Apache Spark. This is the typical view. And Michael now showed you this view and explained, and this is what they think are the 5 components. But I like to tear things apart and look under the covers. Oops, back here. And say there's a lot more going on in here. First of all, my favorite favorite thing is ACA. What's ACA? Well, ACA is really making Spark Core. What's it doing? It's making the threads for it. Cutting back, we know some of these things have already been talked about. Incredible set of numerical algorithms that not everyone talks about, especially Breeze in there. You can hook up NVIDIA GPUs with it. You can even go with NetLib, which is a Java library that gets you back to Fortran algorithms. So all the usual suspects can be brought into Spark and everything. And of course, most data scientists' favorite notebook is IPython, driven by iSpark. Another thing here is they're working on another notebook, which is going to work in Scala, attached to Play, which is TypeSafe, which is the Scala company with ACA and Play. So that'll be a much more Spark-centric type of notebook in here. Finally, the Reactive Manifesto. Well, we know we have to be responsive. We use the elastic. Netflix, for example, stays on Amazon because they like the elasticity of the big cloud. And the other two things, which I think are most important, is RDDs. I think RDD is maybe one of the greatest inventions in the last couple of years, just because I think it's really good to put a functional wrapper around the data set. And because once you do that, you can use it in a million ways. It also, as we'll see a little bit more later, it does hold up. If one of your servers goes down, RDD has a good chance of reconstructing the data for you. And message-driven. Well, really message-driven is also a way of wrapping things. Sometimes we used to change state with objects. I say sometimes it's better to recontextualize and wrap your objects and make your objects immutable in there. Okay, so we've said a lot about being responsive because I think my head hurts now from other presentations, but in a good way, because I think this, there's way too much streaming, way too much data. It's beginning to scare me a little bit. So, but I'm also recommending that maybe the best way to be responsive, back to what Michael said, let's use some statistics to actually, let's strip down, let's shrink some of these sample populations and classify them. So let's not lose good core, keep our common sense. Let's not lose core common sense. Elasticity, again, I say it's the cloud and also the work that's been done with Mesos and Yarn and everything. And really borrowing some of the best ideas from Hadoop in there. Another thing I tell clients, they always want to go into cheap, and the most expensive thing on the cloud is data. I say no, spend the extra money, replicate it. You'll thank me later. Resiliency, I think the focus, as I mentioned earlier, is the resilient data sets in there. I think that having the system, at least make a reasonable attempt to maintain, because we're going to be scaling up to thousands of servers. You're guaranteed some of them are going to go wrong, so you need that built-in resiliency. And then finally, message-driven, which I'm saying is beginning to get into the functional programming and Apache streaming. In fact, another thing I'm going to do another talk on is to mention where you can pretty much do classic data science with Apache Spark, with just RDDs and streaming in there, and have a full stack of tools and everything. And the biggest thing is that we have a lot of components coming into them. Some people I'm doing another talk where I can shoot down, use message-driven techniques and reactive techniques to do away with model view controlling. So message-driven is really our final paradigm. And references and the end. Thank you very much.